Problem 643, LeetCode. The essence of the problem is to process the digits of an array. The goal is to select a certain number of digits, calculate their average, and do this for all possible groups. For these kinds of subarrays, we need to choose the one with the maximum possible average value. So what exactly is a subarray and what is a window? That is, we have a length. Let's take a look. Here it says that we have a certain number k. In our case, that's 4. This is the number of digits that should be in our subarray, 1, 2, 3, 4. So these digits make up the window that we need to consider. It must be complete in order to calculate the average value. What did we do first? We divided this first window, which contains the number of digits that was specified for us. In our case, that's 4. We calculated the average value here, then shifted our window. And here the digits in our window were updated again. Now it became 12-5-6-50. And then we shifted the window once more. So we ended up with 3 different windows. In these 3 different windows, we need to sum up all the digits each time and calculate the average. And all these averages, which are our results, we compare with each other and return the highest result. This is the main thing we need to do directly in the task itself. That's what's stated here. Here we have an integer array, this array with all the digits. And k, this is the number of digits that should be in the subarray. A subarray, if you're just starting to learn algorithms, maybe this word is unfamiliar to you. A subarray is a part of an array that you need to do something with. So here we have an array of 6 digits. And we have a subarray, for example, of 4 digits. In general, there are a lot of problems involving subarrays. For example, there are examples with strings. If you have a string and you need to do something with the first 3 characters, for instance, and so on. In other words, a subarray is a part of an array, and it's within this array. That's what a subarray is. So if you see something like the component subarray, it means you'll be working with a subarray. And here I want to immediately point out that this is, again, a keyword that lets us roughly understand right away what type of problem we're dealing with if you see subarray. Then most likely you'll be working on a sliding window problem. They can be of fixed length or dynamic length. Sometimes the window has a fixed length of 4, and other times the window can shrink or expand. It might shrink to 2 under certain conditions, or it can expand to 5 under other conditions. We'll be solving problems with different types of windows later on, so be sure to keep watching the video. But specifically in this case, we are told that the window must include 4 characters. And for me, as someone solving the problem, when I see these keywords, subarray and length, it definitely means that I will be working with a sliding window of a certain length, a fixed size. That's it. And naturally, this particular type of problem has its own solution pattern. And it doesn't matter what I'm asked to calculate. That's 75% of the problem. I already know how to solve it because I know how to implement this sliding window. What exactly I need to do with these numbers next, inside this window, is not as important. The minimum average number, the maximum average number, remove all the negative numbers, add 1 to all these numbers. For example, it doesn't matter. If I just know that I'm working with a sliding window of fixed length, then I already know what needs to be done, and I'd say that 75% of the problem is already solved. All right, let's see how the math works in this case. First, so we add up the first 4 characters. This gives us the following. This one here, 12, minus 5, minus 6. We add them all up here and divide by 4. Why by 4? Because we have 4 characters in our window, and in this way we get an average value of 0.5. I've already done all these calculations for all the windows. In the second window, when we shift our window, we get the following. Over here, this is what we get. 12 minus 5 minus 6, 50. We divide by 4 and get 12.75. And if we shift it again, we get this kind of math. There you go. So in this way, we shifted this window 3 times. And we got 3 subarrays. 1, 2, 3. This is the first subarray, these numbers here. This is the second subarray, these numbers here. And the third subarray, these numbers here. We took the average values from each of these arrays, and we ended up with these results. Now all that's left is to take the maximum from these results. Here, it's obvious that this is the maximum result. Here, I want to say once again that if you understand what is being asked of you, this is the most important thing. When you start solving problems, even without writing a single line of code, you can already figure out what the solution is. That needs to be implemented. And secondly, if you are able to identify a known solution pattern, for example, the sliding window. In this case, you can, with the help of just a simple mathematical manipulation like this, already know the result. Here on LeetCode, they immediately tell you the result, but in an interview, no one will tell you the answer right away. But if you have identified all the keywords, recognized this pattern, and worked out the math, whether on a piece of paper or in your head, then at the very least, before you start writing the actual code, you already have a concrete solution and know exactly what you need to do. Now let's move directly to the code. The code looks like this. So first we create our window. The very first window is created from our first 4 elements. That is, we have the first, second, third, and fourth elements. That's it. And at the very beginning, before we start moving it, our window looks like this. In Python, it looks like this. That's it. First, we create this window. In Python, we use a colon and then K. And in this specific way, we carefully take all of the characters, these first 4 distinct characters. And then, right here in this step, we sum them all up together. So, as you can see, this is the specific total sum that we definitely need to calculate right here. However, after we find that sum, we actually need to return the final average instead. And first we calculate it, specifically this sum of the first 4 characters using this kind of construction. And then we divide by 4 to get the very first result. So first, actually, in principle, this can be done in a single line, but I did it in 2 lines to make it clearer for you. First, we find this sum using this line of code, and then we do the final calculation to get the first result. Why do we need it? Because we will compare the second and third results starting from here. So when we get to the second result, we will need to compare whether this one is greater or that one is greater. Once we are ready to compare, we have this result. 0.5, we can start moving our window. Here, when preparing our window, we need to make sure that we start moving our window, taking into account the fact that the first 4 values are already in our window. This is done in Python using the following. This kind of construction we write for I in range. And in range, we specifically indicate that we have k. This means that this is the start of our array. This means that our loop will not start from 0, but it will start from the value k and go all the way to the end, up, to the end of the length of our array. What do we do next? We have these sliding window pointers. And from our window itself, from this specific position, we perform a detailed mathematical calculation and manipulation process. We subtract it from this current set. And when we shift the frame like this, over here to the next position, we remove this specific numerical value, the one right at the start, see? And we add 50. So in this way right here, 50 is added to the end, and the one that was here, it disappears. And in this way, we get a new subarray, 12-5-6-50. In the code, it looks like this. We add 50 right here. This one. And here we perform the subtraction of exactly 1 unit. So the specific numerical value that is currently in our window is then successfully updated to reflect the change. And we add a new element. Next, we calculate the average again. And this average that we have here, that's this number. We use it in a new operation with this max function. We say calculate which is greater, 0.5 or 12.75. Naturally, it picks 12.75, and we update our result variable with 12.75. Then the same thing happens again. That is, we shift this window, remove the 12 from here, and add the 3. Then exactly the same thing happens again. That's what's being done here. Again, exactly the same thing. We calculate the average, and we get 10.5. And then, using this max function, we choose whether 12.75 is greater or 10.5 is greater. 12.75 is greater, so our result doesn't update, and we return the result. In the end, that's what the solution looks like. The sliding window is a very common pattern that you can encounter in interviews. I highly recommend you practice it. Be sure to subscribe to my channel and write in the comments which problems you'd like to see explained. And check out the additional videos related to this problem on my channel.